So this section talks about some concepts that you've already learned, but they may give different definitions, or different terms to some of the things that you've already done. But before we get to that, let's review what intercepts are. Important features of a graph of most functions include the intercepts of the graph. The intercepts of a graph are points where the graph touches or crosses an axis. A y-intercept of a graph is the y-coordinate of any point where the graph intersects the y-axis. Similarly, the x-intercept is the x-coordinate of any point where the graph intersects the x-axis. So if we look at example number 1, it just simply says find the x and y intercepts of the graph of y equals half x squared plus half x minus 6, which is shown at the right. Now, eventually we're going to learn how to graph that, but today we're just going to focus on how to read a graph and find the intercepts. So in order to find the x-intercepts, we would look to see where it crosses the x-axis. And it crosses the x-axis right here and right here at those 2 points. So this is an x value of 3, so one of the x-intercepts would be 3. And over here, that is an x value of 4, or an x point of 4, 0, so we would say that is an x-intercept of 4. So we could say the x-intercepts are, negative 4. We could say the x-intercepts are negative 4 and 3. To find the y-intercept, we're going to see where it crosses the y-axis, and it crosses the y-axis down there. So there's only one y-intercept, and that y-intercept is going to be negative 1, negative 2, negative 3, negative 4, negative 5 at negative 6. So a y-intercept of negative 6. So a couple of definitions, or terms, has definitions that are very similar to each other. The solution of an equation is called the roots of the equation. So in Algebra 1, you would be asked to solve an equation. Basically, you'd be solving for x. Whenever you're asked to solve or find the root of an equation, that's what you're doing, is you're solving the equation. So it's no change of something that you've already done. The root of an equation is related to the zero of the function. The zero of a function, f, is the value of x, in which makes f of x equal to 0. So it's very similar to finding the root of an equation. To find the zero of a function is you would set the function equal to 0 and solve it just like you would when you were in Algebra 1. So example number 2, it says find the root of the linear equation negative 2x plus 10 equals 0. So to find the root of that equation, that literally just means to solve it. That's all it means, solve it. So we would solve this by subtracting 10 from both sides. You get negative 2x equals negative 10. Divide by negative 2. And you would get x equal to 5. That is the root of the equation, x equals 5. If you look at the graph, you can see that the graph already has the equation y equals negative 2x plus 10 graphed for you. So you would graph that by going up to positive 10, placing a point there, and then you would go down 2 over 1, and this graph is going by 2's, so down 2 would be down 1, 2, and over 1 would be just a half a box, so right there. Down 2 over 1, and so on, and you can see that they've already connected the points with a blue line. So notice that the x-intercept right here just so happens to have the same value as the root. That is not a coincidence, because not only are the roots and the zeros very similarly done, the x-intercept is also very similarly done. So if you're asked to find the roots, zeros, or x-intercepts, to find zeros and x-intercepts just simply means you're going to set the function equal to 0 and solve. Roots, sometimes when they do roots, it's set equal to another number, but that doesn't mean anything different. You're just still going to solve it. So don't overthink anything. The biggest issue with these is just simply what does the word root and what does it mean to find the zeros of the function? These are going to be used throughout the year, so it's best to learn them as soon as possible. Finally, we need to talk about how to find the x and y intercepts when you don't have the graphs drawn out for you. We don't want to graph everything and try to find the intercepts because sometimes the intercepts might be fractions or decimals or really large numbers, and it's just not very practical to graph everything, especially if the numbers are very, very large or very, very small. So before we do that, I want to analyze a graph. And I'm going to draw some random lines on this graph. So let's see. Let's draw a red line just going right through, we'll say right through here. And let's use a blue line. Let's do a blue line right through here. And let's do a green line. Again, these are just completely random. Let's do a green line this way. Okay. So going with the red line, let's first talk about the x-intercept. So we can see that the x-intercept is right here. So what is the coordinate of that point? Well, the coordinate of that x-intercept is at 2, 0. And let's go to the blue, and let's see, the blue has an x-intercept right there. And the coordinate of that point is at 4, 0. And we go to the green. The green has an x-intercept right there. And it looks like it's about negative 4.5, 0. So what do all three of those points have in common? And all three of those points have in common is that they all have the same y value. The y values are all 0. And that's because as soon as you touch the x-axis where the x-intercept is located, the y value is always going to be 0. So, in order to find an x-intercept, what we're going to do is set y equal to 0 and solve it. So for an x-intercept, set y equal to 0 and solve. So we replace the y with 0. We get 0 equals 3x minus 3. And we would solve that by adding 3 to both sides. So 3 equals 3x divided by 3. So we have an x-intercept of 1. So let's go back to our graph and our random lines and talk about the y-intercepts. So going with the red line, the y-intercept is located right there. So that looks like it is located at 0, negative 4. And if I go to the blue line, the y-intercept looks to be right here. And so let's see, that looks to be 0, 2. And what is the point where the green y-intercept is? And that's about right here. And I would say that is about 0, negative 6.5. Yeah, let's try to draw that a little bit nicer. Negative 6.5. There you go. You can probably read that better. So what do the y-intercepts have in common? And hopefully you can see that the y-intercepts all have the same x value, and that x value equals 0. Because as soon as the graph touches the y-axis, at that point, the x values will always be 0. So in order to find the y-intercept, you're going to set x equal to 0 and solve. This time you'll set x equal to 0 and solve. So going back to the original problem, I'm now going to set x equal to 0. So I would have 3 times 0 minus 3 and then solve for y. And 3 times 0 minus 3 is just negative 3. So the answer for the y-intercept is negative 3. Yes, you could look at just the b value because this is in slope-intercept form. It's y equals mx plus b. And yeah, you could just look at the b value to get the same answer. And that's exactly why the b value is the y-intercept, is because when you replace the x with 0, 3 times 0 is 0, so all that you're left with is negative 3. Doing these intercepts are more general ways of finding intercepts of not just limes, but for any of the parent functions that we're going to be dealing with in future months. So go ahead and practice trying to solve the x and the y-intercepts using this method, even though you could probably figure it out that the y-intercepts is going to be that last number. So let's do the next example over there. And notice this one's written in function notation, but we already know that that just means that if it's in function notation, it still means y equals that function. So I'm just going to rewrite that with a y. So it's y equals 6x plus 3. So in order to find the x-intercept, we are going to replace the y with 0. So we'd get 0 equals 6x plus 3. And we're going to solve for x. So subtract 3. So negative 3 equals 6x. Divide by 6. And x is going to be negative 3 divided by 6 is negative 1/2. Don't leave it unsimplified. Simplify it. And then we'll do the same thing with the y-intercept. And again, for practice, we will now set the x equal to 0. So we would have y equals 6 times 0 plus 3. 6 times 0 plus 3 is just 3. So this has a y-intercept of negative 3, which does match with what we would expect it to match, the b value of 3.